I'm Alex Saroyan. I'm a CEO and co-founder of Netris. Our users are NetOps, DevOps engineers, infrastructure ops engineers. They love Netris because Netris helps them to run their physical data center networks like it is a cloud. SDN, intent-based networking, all these amazing technologies are doing great job for network automation. VPC networking, like the one we see in public cloud, is for self-service. I started my career as a network engineer about 20 years ago, and just like probably many of you folks, I've started from learning standard Cisco commands, using conft and using spreadsheets for storing IP addresses and other information. Over time, I've learned programming, so I can run automation scripts. And then moving forward, I've embraced software-defined networking, APIs, all that stuff, just to become better network engineer. But cloud kind of set the new user experience standard for DevOps engineers, for those who are into cloud native. And in public cloud, DevOps engineers kind of expect that they're gonna go log into console, they're gonna request resources, slap on the applications across multiple regions and zones, click OK, and it should be up and running in seconds. That's how the expectation is. So as a network engineer, I think about DevOps engineers like my customers. So that's the experience that my customers want. So how do I deliver that? And that's the question which I will try to answer during this presentation. So if we look at evolution of on-prem network operations technologies, and I like looking to this in both from network engineering perspective and also from DevOps engineering perspective. How much things are helping network engineers do their job and how much things are helping DevOps engineers do whatever they want to do. So industry started with a CLI and then automation, and then industry came up with the software-defined networking and intent-based networking. Those all are amazing technologies that are doing great job for traditional data center and telco environments. But they are not fundamentally designed for cloud-native DevOps engineers. I can't imagine DevOps engineer going into one of these consoles and creating a network services for them. But this is what they do in public cloud. So what they want VPC networking. They want self-service VPC networking. And if we think about tools that they are using, in public cloud, they use GUI that is immediately touching the infrastructure. They use Terraform to request resources. They use APIs. They use application platforms that are deeply integrated with the network, like Kubernetes, but in public cloud. So when we take this type of engineer into on-prem, what are they gonna face? They're gonna face ticketing systems, emails, calls. At best, they're gonna face VMware NSX, which does it better. It makes things easier, but VMware NSX doesn't handle the physical networking. So in my opinion, DevOps, they don't need another API which is network specific. They don't want to deal with the networking constructs. They want to deal with the VPC type networking, but on-prem. So how do we make this happen? Netris is specifically created to address this use case. We have a controller which is designed for both NetOps engineers and DevOps engineers to use the same controller. NetOps engineers can find things that they are interested, like switches and routers, and DevOps engineers will find things that are important for them. And there's this layer of hardware underneath that our software is managing automatically behind the scenes. So DevOps and NetOps can just focus doing on their thing. This is a lab in Santa Clara here, one of our test labs. And I'm gonna run a little demo using this lab. So there's network equipment, there's servers, and this presentation is focused on DevOps side of things, while my other presentation covers NetOps side of things. But let's see how it looks like for a DevOps engineer doing his stuff, a cloud native DevOps engineer creating services on this, literally this environment. So, in this environment, I'm speaking like I'm the DevOps engineer or infrastructure engineer. So I've got a bunch of servers, virtual servers. Theoretically can be any virtualization can be used, but I'm currently using KVM. Doesn't really matter. The point is I've got a bunch of servers, and in this console here, I'm using this console to access, just to get on one of the servers using management network with a jump server. And this server, my goal is to run a Kubernetes cluster on this server. And if I look at the cluster, the Kubernetes itself is installed on the server, but it doesn't work because there's probably no network. And I can see that there's this IP address configured here. Sorry. There's IP address and default gateway configured, but I can't ping my default gateway. I can't ping my neighbor servers. So that's probably why Kubernetes cluster doesn't work. And in traditional world, I would need to go and communicate with network engineers, but this is cloud native use case. I'm a DevOps coming from public cloud. I want to self-service. I want to create this service myself. So I will log into Netris console, and I will go to services, virtual network, and I can see that there's no service defined here. That's why it doesn't work. So I will leave ping here on as an indicator. So when things work, I will see it working. And I'm gonna try to create my first service. Let's call it Kube. I'm creating a virtual network. I'm selecting the data center. This thing can work across multiple data centers. I'm selecting California data center. Then I want to add IP addresses to the service. And in this list here, I can see the list of IP addresses that I am allowed to use. So basically, network engineers allowed me to use one of these IP subnets. I'm gonna use that. I'm gonna involve switch ports into this service. And I'm a DevOps engineer. I'm not gonna think about figuring out which ports do I need, which ports do I not need. I'm gonna select just everything. I'm gonna select untag. What the hell is this? I click add, and there's a bunch of things there. But as long as network engineers are fine with this, it should be okay, right? I click add. This thing says provisioning. Is provisioning. And now we can see that ping responses. I can try to ping my neighbor servers. I can access other servers on the network. I can try to see if I have access to the internet. Okay, these things work. Now, it will take some time for Kubernetes cluster to become a cluster, but to save your time, I'm gonna reboot this Kubernetes master node machines. And while Kubernetes is rebooting, I'll go back to my presentation and describe what happened behind the scenes. So as a DevOps engineer, I went there and I said, hey, Netris, can we put this bunch of ports into a service and use these IP addresses I just need for my servers. What Netris did behind the scenes, Netris automatically has decided to configure a VXLAN network with a EVPN signaling across all the switches that happen to be involved, connected to this bunch of servers. There's about 9 servers involved in this Kubernetes cluster. And then I've selected a network for network of IP addresses. So Netris behind the scenes decided to configure first IP address as a default gateway on every single switch using, VXLAN, Anycast default gateway technique. And we have these things called soft gate, these top things here, this one and that one. So soft gates are Linux machines with a SmartNIC card and DPDK acceleration. So those are like a cloud gateway. In public cloud, we have cloud gateway. In on-prem, we need something like that, and that's soft gate. So these machines, they handle your network address translation, your layer 4 load balancing, your site-to-site VPN, and if you need to connect with the internet upstream, these things can do full routing table, kind of like replace traditional routers. But we'll speak about that in other presentation. So we've got that connection done, we've enabled NAT, and the next step is to check how the Kubernetes cluster is doing. We can see that now Kubernetes cluster has formed. There are this bunch of nodes in a Kubernetes cluster. Now, this network that DevOps engineer is using here is using private IP addresses, 192.168, and so on. But I want to connect to this. I don't want to use this remote console. I don't want to use this jump server. This is not how we do things in public cloud. I want to use kubectl, the client on my laptop. I want to connect to this Kubernetes cluster remotely. And in public cloud, DevOps engineer would either request an elastic IP address or would use an elastic load balancer. That's what I'm gonna use because I have there 2 kube API nodes and I wanna connect them over the internet, but also I wanna organize redundancy and load balancing. So in public cloud, that would be ELB. Here in Netris, I go to this thing called layer 4 load balancer, L4 load balancer. And I can configure one using web console, put some name, select the protocol TCP, select the data center, select the health checks, and add backend IP addresses, select front-end IP address. But I'm lazy DevOps engineer, and I want to use this with Terraform, so that way it's just easy. So in Terraform registry, there is this provider called Netris, and we can see that documentation is super simple. It's just using the standard constructs, and there's bunch of resources that this provider can provide, and I'm gonna use only one resource, a layer 4 load balancer resource, this one. And to save your time, I have prepared my Terraform file. Here is it. So here I'm basically saying, hey, Mr. Netris, can you please create a load balancer resource? Could you please let me use this specific front-end IP address if it happens to be available? If no, let me know. Those are my backend IP addresses. So just load balance traffic coming here towards these backend IP addresses. Why I'm doing that? Because I want to use kubectl to access my Kubernetes cluster, but I cannot do this because this access doesn't exist. If we check my config of Kubernetes of kubectl, we can see that I'm trying to access this URL, which points to exactly the same IP address that I'm trying to request in this load balancer through Terraform. So as an indicator that it's available, I will start a ping here, and I will run this Terraform directory. Okay, now when that is executed, we're gonna see this service has been configured in Web Console of Netris. It is still in the process of provisioning. We can see that front-end IP address is already responding, so it basically happened to be somewhere configured already. It's Netris just configured it somewhere, but it's still waiting on health check because Netris wants to make sure that backends are actually responding. So now health checks are green, and we can go back to Kubernetes cluster. And we can see that now I'm able to access my Kubernetes cluster remotely. So far, I've got cluster networking enabled, and I've got remote access to my cluster. What happened behind the scenes, I've used Terraform provider to instruct Netris controller to provide layer 4 load balancer. Netris looked into my hardware, into inventory, into topology, and Netris thought like, okay, I have access to these 2 softgate nodes. I'm gonna implement this layer 4 load balancer using these softgates. That's what happened, and then traffic started to flow. Now, we needed this cluster for a reason, right? I'm a DevOps engineer. In this case, I need to launch an application. So for this purpose, I'm using this super simple application called pod.info. And here is the YAML file description of this application. If I apply this YAML into a public cloud without any changes, it will deploy and it will run. It's using just exactly the same standard constructs that any Kubernetes cluster, any flavor of Kubernetes cluster. And for exposing the application into public internet, I'm using here this construct called load balancer. This is standard Kubernetes construct, which assumes that the cloud environment has the ways to provide load balancing service. So this requires Kubernetes and network environment kind of interoperability kind of integration. So I have deployed this application, and we can see that Kubernetes is saying external IP pending. There is no external IP available yet. And if we look into Netris Web Console, we will see that a new load balancer instance has been automatically provisioned. Netris picked the next available public IP address from the pool and assigned this IP address to me. I didn't mention specific IP address. Same for the backends. I didn't mention what are my backends. This is just one of 7 node servers that Kubernetes happened to run this particular application on it. So Netris identified that IP address and put that as a part of load balancer service. Now going back to Kubernetes, we will see that Kubernetes knows the IP address. So Netris pushed that IP address back into Kubernetes. And let's see if that application even works. Now we can see I'm accessing this newly deployed application in Santa Clara from my laptop here. It works. Now, when application works, people start using it, you're getting traffic. And if I check back my Kubernetes cluster, I'm gonna see that there's only single pod servicing this application. And when I get a lot of users, this is not gonna be enough. And what DevOps engineers do in that case, they just scale the deployment. And I'm gonna scale it. I'm gonna request Kubernetes to scale deployment called pod info with the 10 replicas. So basically I'm saying, hey, Kubernetes, could you please now run 9 more containers? And Kubernetes will decide to launch these containers on a whole bunch of different physical nodes. And look what happens behind the scenes. Netris has detected these other IP addresses of these other nodes, added them into load balancer. We're not sending traffic there yet because we want to make sure that application is responding. Health is okay. And once they all are green, now it's done and it's up and running. Let's see if it still works. So this is the address. Now it works. So what happened behind the scenes, we have a little Netris operator sitting inside the Kubernetes cluster. It's just a standard Kubernetes construct using standard Kubernetes methods for doing this. You install Netris operator using just Kubernetes commands. That Netris operator from the Kubernetes cluster communicates with Netris controller, provides Netris controller with the necessary metadata, data of applications, and based on the data, Netris figures out how and when to make, to provision load balancers or change routing or do whatever it is required.
So where is the Netris operator running? Is that running on the switch or is it running on the servers?
Netris operator running on top of Kubernetes cluster. We can see it.
Okay, so it's the Kubernetes servers.
Mm-hmm.
Okay. So it's not an agent running on a switch.
No.
Okay.
No. There is it.
How about the VXLAN EVPN? Is that running in the cluster, or you're using the switching for that?
The VXLAN EVPN that we've provisioned in prior example, that runs physically on the switches.
Okay. What switches do you support for?
My other presentation covers everything from NetOps perspective.
Okay.
Let's get back to it.
And then just to finish it off, the Netris controller is a separate appliance that's running in your data center.
Right.
Okay.
And in other presentation, we're going to install one.
If I'm a DevOps engineer and I'm deploying a net new Kubernetes cluster in the public cloud, so I'm provisioning the networking, I'm provisioning the KAS cluster, I'm doing that without having access to, let's say, an EC2 instance or a GCE instance. I'm doing that via the cloud console itself. So I wouldn't have a Kubernetes pod that doesn't have network connectivity. So that, like the beginning of, I can't get past that first part of the demo in which you showed that there was a KAS cluster without connectivity. That kind of confuses me.
What's the flow, both in public cloud and everywhere? Everything starts with the network, right? Mm-hmm. In public cloud, if you're a DevOps engineer, you either gonna use like GKE, things like that, or if you wanna install your own, just a vanilla Kubernetes, you may request a bunch of VMs. But in both cases, everything starts with a VPC.
Right.
Network engineer goes to cloud, creates a new VPC, which is the networking of the cloud. That's VPC networking. I go there, create new VPC. I put there some IP addresses. Those are the ones I want to use. I select if I want to use NAT or not, things like that, very high level, right? And then I click OK, I get the network ready. Now my VMs or my Kubernetes cluster, whatever it is, has access to the internet, and then I can install whatever it is that I'm gonna use there. To install something, you need internet connection. In this demo, just to save everyone's time, we have installed the Kubernetes cluster before coming here and just turn it down, just to make it fast. So turn down the network. Then I have requested, as a DevOps engineer, I have requested a new VNet, just like a VPC in public cloud. Netris has provided that. And then when I've got the connectivity, I would able to install a new Kubernetes cluster, but I've used the one that I have pre-installed.
Okay, so I'm going to repeat that back just to make sure I got it, because I was a little chicken and egging there as well. So the first thing that really happens is we create the VNet in the Netris controller that resides in that data center. And we could have pretended for all intents and purposes that that first part where you were showing us the Kubernetes cluster never happened. Like it just didn't exist before.
Mm-hmm.
So step one, create the VNet.
Right.
Now that we've created the VNet, how do we do the next part where we quote turn on the Kubernetes cluster, right? That's, I guess, the part that
So I guess we did a little, so what he showed us was that there was and this is what threw me off because we're connected to a VM instance. And I'm assuming we're connected, since we're in the data center, we could connect over the web console to the VGA just remote desktop type deal. So you have there was a VPC that just wasn't turned on.
Yeah.
So he turned on the VPC via their control plane, and that lit up the networking behind the instance.
Yeah.
So I can, since I'm a VMware guy, I can kind of picture that. But I think if anybody's native to cloud native coming into the beginning of that presentation, they'll really throw them out because there's like no way to do that in AWS or GKE or Google or Azure. You can't have a OS instance without a VPC.
Right.
Yeah, if in public cloud, if you delete your VPC, your cluster running under it will disappear. Yeah. No, this is created just to save your time for this demo. But in real life, our customers, they create VNet, then they install Kubernetes cluster. They don't use pre-installed Kubernetes cluster. It doesn't make sense for other than demo.
Okay, that makes sense. Yeah. Thank you.
With this, you're using Kubernetes as kind of our cloud or our containerized platform. Is this only for Kubernetes, or is this just kind of for the demo, but you could use whatever you wanted?
You can use everything. Our customers are using VMware, are using just bare metal machines, using KVM, and also Kubernetes. It's just a nice way to show.
Okay.
Oh, okay. So this isn't an exclusive Kubernetes play. I'm just using Kubernetes as a way to demonstrate some application.
Just like in public cloud, it's not Kubernetes only. In public cloud, you may have a bunch of VMs. You may have some service X, some specific service X, or you can have Kubernetes. It's just the same. The main point is that whatever it is that you are using, Kubernetes or VMs or bare metal, the point is that DevOps engineer can self-service, just like the VPC. So we're making Netris to be the VPC for on-prem.
I see.
So is there a separation of constructs between the DevOps and NetOps? So from a DevOps perspective, I don't know what the underlay is. It can be all virtualization, it can be all bare metal, whatever. The NetOps folks have provided that to me, and Netris just rides on top of that.
Exactly. And here, when DevOps engineer is accessing different Netris services, there's only VNets, load balancer, things that DevOps engineer can understand. Mm-hmm. The physical switches, routers, routing and things like this exist, but they are hidden. They happen behind the scenes. But I will show in my other presentation in more details.
So just to go one step further. So if I'm a DevOps and DevOps engineer, what I like to call a platform engineer. If I'm a platform engineer and I need to create a set of cloud services for my developers to consume, this is the VPC component of a larger infrastructure or platform play. I can have you gave the Terraform example, but I can have a Terraform REST playbook, whatever they call it, that brings up a whole set of Kubernetes clusters with IAM and a bunch of other stuff. This is just the platform view of managing my VPC in related services.
Right. Netris is just VPC, and we think the whole private cloud, like a single company probably cannot cover that private cloud thing. We're not trying. We're just trying to cover the VPC thing, and compute platforms will plug into that. We're working on that. Like the part where I have selected the ports, that part gonna go away. We're working on that, and later in the year we will show that, but it's still work in process.
Yeah, so if I wanted to team this with something, I'd probably put it with like a Red Hat or something like that to complete my private cloud. But this goes beyond what a Red Hat can do from a VPC perspective.
Yeah, exactly. We handle that physical networking part. I don't want to rush and say names, but we're working on it.
Yeah, I'm guessing you might cover this in the NetOps portion, but one of the things with public cloud is kind of that elasticity idea. If you're going through and allowing developers to create load balancing, is there a way to kind of put some rails on how much they can deploy before they kind of topple an environment? Because you give somebody the ability to create something, they're gonna go. And I can't expand an environment as quickly as AWS can.
Yeah, exactly. So I guess is the question is more about like, is this safe at all? Like, aren't we giving
a way to prevent somebody from kind of saturating? I mean, if you've got your those SGs, like if there's only so many cores, there's only so much hardware I can put to them. Is there a way that I can say, once we hit 20 load balancers, we're topped out until we add resources?
Yeah, we monitor everything. If there's high load somewhere, we're gonna let you know. Let network engineers know, not DevOps engineers. So network engineers know, oh, I need another soft gate. I need another upstream connection. I need to upgrade this link. Things like that.